Welcome to Leetcode JavaScript, a channel where we solve every single Leetcode problem using JavaScript. Okay, so right now we have Leetcode number 2 at two numbers. This is a medium question related to linked list, which is something many people have issues with. Not because it's particularly hard or complex, but it's not something that's usually very well known at the time of code implementation and code writing. So let's go right through it. You're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contain a single digit. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zeros except for the number 0 itself. Okay, so in this example, we have the following linked list. This being the head. We have 2, then 4, then 3, then 5, then 6, then 4. And the answer is 7, then 0, then 8. But remember, these numbers are in reverse order. So this is 342 plus 465, which equals 807. We have another example when 0 plus 0 is equal to 0. And we can also see we may have to, some numbers that are large, and we may end up with more digits than we started with, okay? Now, this, again, isn't a super complicated problem, but you just kind of have to know how to work with linked list, and this is a perfect problem to start with it. So whenever we're making a sum of two numbers, something that comes up again and again is a remainder. And I'm gonna give you the answer right away. I'm gonna let you know that you're gonna need a carry on or a remainder that's equal to, initially it's gonna be equal to 0. For example, here 4 plus 6 is 10, and you gotta carry the 1, right? So we're gonna start with a couple edge cases. I think it's always the best idea to start with edge cases. What's the best edge? What are the most common edge cases that we may find? So if L1 and L2, and those are our lists, by the way, if maybe they're not there, and carry is equal to 0, then we return null. Okay, and this is the largest edge case, and in the case we don't have a node for L1 or L2. All right, so we can start with a number A, which we ask ourselves, do we have an L1? And sometimes we may not, because as you can see here we have one number that has more digits than the other. So there might be cases where you just don't have a corresponding number to sum. So do we have L1? In the case that we do, we take its value. Otherwise, we take 0. Let's repeat this for L2. 2.val and 0. By the way, you can see the implementation of list node over here. That's the one I'm using. You see it's relatively simple and straightforward. Make sure to check the implementation for whenever you're in an interview or elsewhere to make sure you're using the correct one. Okay, so we're also gonna need what's my next value, and we have a next value of L1. Again, if L1 is available, you take the next, otherwise it's gonna be null because it doesn't exist. And we also want to know the next for L2. To the next or no. Okay, so far so good. Now the sum that we're actually gonna carry on is gonna be A plus B plus a carry number if it exists. And carry is gonna be a sign after the sun. It's gonna be the math.floor oh, sorry about that. Okay, it's gonna be math.floor of sum divided by 10. And let me give you an example. If 6 plus 6, this is gonna be equal to 12. If we divide that by 2, it's gonna be 1.2. Math.floor eliminates any decimal value that this number may have, and we end up with a 1 to carry. If you think about it, the largest number we could possibly have is 9 plus 9. And 9 plus 9 is 18. And 1.8, if we just floor it, it's going to be equal to 1. So the only value we will ever carry is the 1. And for smaller numbers, there is 1 plus 2, it's going to be equal to 3. It's going to be equal to 0.3. When we floor it, it's going to be equal to 0. So we just carry 0, which is essentially nothing. Okay. And afterwards, we take sum to be equal to sum modulo 10, such that we, I should call this sum. All right. Sum is equal to sum modulo 10, such that it gets reset to the minimum value. That's being the last digit. And we're gonna return a list node. And in this case, you can see that actually a list node is an object. So this may not look the prettiest, but it's just so we can make it pass for Leetcode. And val is actually going to be equal to sum. And next is going to be equal to add two numbers. Next L1 and next L2. Now let me explain myself here. When we do the modulo 10 here, we assure ourselves that we only get the last digit. For example, if we had 5 plus 6, that's going to be equal to 11. But when we modulo 10 it, we only get the 1. And in this case, we also get the carry, the 1. So we are not worried about losing anything. Now, for next, this is called a recursive step. Recursion is quite commonly used for linked list. And we simply, given that we have L1 and L2 next, we are just gonna keep calling the sum until we run out of nodes to make a sum of. And here in this edge case is also the case that causes termination whenever we run out of stuff to do. Is, well, we have L1 and L2, and if they're not available when we call them, in this case meaning there's no next, so it's null, and there's no carry, it might be a 1 to carry just at the end. In that case, we return null, and then our function stops. So let's actually run this code and see if it works. Oh yeah, I forgot a comma. Since this is an object, I need to use a comma. All right. And there you go. That's accepted. And let's actually try submitting this. And there you go. This is a relatively good answer. There are other answers that involve iteration, but I think that's something that maybe better showcase on a different problem. So that's gonna be it for this problem for today. Thank you so much for watching. Don't forget to like and subscribe.